Boom! Hey, this is Mr. Kingsbury, and guess what? I'm here representing Algebra 2. We moved on to our next unit, which is Systems of Equations. We're going to be building on the knowledge that you gained in Algebra 1 about systems of equations. Don't forget to put the date and the period. Today we're going to start by reviewing what you learned in Algebra 1, and what you learned was how to solve systems of two equations with two unknowns. In fact, that is our essential question. How do I solve a system of two equations with two unknowns? It's a great question, got to be honest. So let's just jump right into it. There are three ways. The first one is graphing. And let's say that you're given the system y equals 1/2 x plus 2, and y equals negative x minus 1. You can automatically go to the calculator right here, and there we go. Type in, go to y equals, and type both of these in. So we got 1/2 x plus 2, and then we've got negative x minus 1. And then I'm going to hit graph, and I should see two lines pop up. And I just want to see where they cross. There's a couple ways to do this. One way would be to hit second, and then hit graph, and go to the table and see which points were the same, have the same y value. It looks like the same y value is right here at negative 2, 1. Another way to do it is to hit second, and then the option trace, and then you use the intersect option, which is 5. And you just hit enter 3 times. And I can explain that to you in class if you want, but it will tell you the intersection is negative 2, 1. That's pretty straightforward. So negative x, y equals negative 2, comma 1. That would be our solution. The next example is substitution. So let's say, for example, that you are given x equals 10 plus 2y. And then the other equation is 1/2 x minus 2y equals 4. Now, up with the graphing one, both of them were solved for a variable. They're both equal to y, right? On the left side, you just have y. On the right side, you have some other stuff. So you would say this is solved for y. Similarly, here in example 2, this first equation is solved for x. That means in the other equation, where you see an x, you can go in and remove that x and put whatever it's equal to in its place. So I could rewrite this equation, and instead of an x, I can put what x is equal to. X is equal to 10 plus 2y. And then I can bring down the minus 2y, and the equals 4, and I now have a whole new equation that I can solve. I can distribute this 1/2, so 1/2 of 10 is 5, and half of 2 is 1, so I have 1y. I didn't write 1 because it's understood that's 1y. Minus 2y equals 4. I can put my like terms together there. So 1 minus 2 is negative 1, so in fact I'm going to put minus 1y, and that equals 4. And now I can just solve it, which is awesome. So I will do that by subtracting 5 from both sides. I get negative 1y equals negative 1. I can divide both sides by negative 1. And I get this. See, negative 1 divided by negative 1 is 1. 1 times y is y. Negative 1 divided by negative 1 is 1. So I get y equals 1. Unfortunately, I'm not done. I have the y value, but I still need the x value. What's great is in the situations where you can use substitution, the equation you used to do the substituting, to figure out what to substitute for what, you can plug this number, your value you solve for, back into it and get the other value. What I mean is, we can start with x equals 10 plus 2y, and then I can replace y with 1. Y equals 1, so I can put 1 in there. So I get x equals 10 plus 2 times 1 is 2, and 10 plus 2 is 12. So x equals 12. So my answer is xy equals 12, comma 1. So that's substitution. The remaining way is elimination. Whoops, example 3. And I actually have, I think, 4 examples of this if I can squeeze them in. I'm running a little short on time trying to do this on my conference period. We'll see what happens. So we'll call this elimination. And all the ones after this are elimination as well. Let's see. So here's my first one. We got 2x plus 5y equals negative 24. And 3x minus 5y equals 14. Now, there's a long explanation as to why this works. But essentially what it boils down to is you're adding the same thing to both sides, but you're doing it in such a way that on one side, the stuff with the same variable, or at least all the stuff with one of the variables, cancels out by making a coefficient of 0. On this first one, I'll do a longer explanation so you can see what's going on here. What I would point out is, first of all, x and y are both on the same side in both equations, both on the left. What's more important is right here. The y's both have a 5 as a coefficient, and one of them is positive and one of them is negative. If you add 5 and negative 5, you get 0. So if I were to add down right now, and when I use elimination, I like to put parentheses. 2x's plus 3x's is 5x's. 5y's plus negative 5y's is 0y's. And negative 24 plus 14 is negative 10. Now, normally you wouldn't write this. You would go right to what's going to show up in 2 more lines for me. But I want you to understand why this works. 0 times y is just 0. So this is really 5x plus 0 equals negative 10. But 5x plus 0 is just 5x. So really, when you add down, as long as the variable has the same coefficient with opposite sides, it essentially eliminates that variable, and we're just left with one variable. So 5 times x equals negative 10. I can divide both sides by 5, and x equals negative 2, which is awesome. And then I can go back to either of these equations and plug that in. I'm just going to go with the top. So we got 2 times x. In this case, x is negative 2. Plus 5y will equal negative 24. My first step is always going to be to multiply this out, whatever I substituted in. 2 times negative 2 is negative 4. So negative 4 plus 5y equals negative 24. And then I will add 4 to both sides. Negative 4 plus 4 is 0. 0 plus 5y is 5y. Negative 24 plus 4 is negative 20. So I now have 5 times y equals negative 20. And then I can divide both sides by 5, and I get that y equals negative 4. So I have my answer, xy equals negative 2, comma, negative 4. Now that's a simple elimination problem. They actually can get more complex, and there are more things that you have to do. That one was simple because it was set up for you. When you came upon it, there was already a variable that had the same coefficient in both equations, and that coefficient had opposite signs. If that isn't the case, you can use multiplication to force that to be the case. And I want to show you a couple examples of how that works. So here we go. Here's example 4. Also using elimination. Let's say we have 2x plus 3y equals 12, and 5x minus y equals 13. Now you'll note the x's have different coefficients, the y have different coefficients. What I do see is that one of the y coefficients, it's not there, but technically it's a 1. That means that we could use multiplication and we could make this coefficient into a 3 by multiplying by whatever you would multiply 1 by to get 3. In fact, that would be 3. Now, you have to make sure you multiply everything in the equation by 3. 3 times 5x is 15x. 3 times negative 1y is negative 3y. And 3 times 13 is 39. And I'm going to rewrite the equation on top right over this, 2x plus 3y equals 12, and then I will add down, and look at what happens. 2x's plus 15x's is 17x's. 3y's plus negative 3y's is 0. It eliminates, and 12 plus 39 is 51. If I divide both sides by 17, I get that x equals, I don't know, I want to say it's 3, and I would be right. So x equals 3. And then I can take that and put it back in one of these equations. It doesn't matter which. I have a tendency to use the one that has the y with the coefficient of 1. That's just me. It doesn't matter. You know what? Just for fun, let's put it in the top here. 2x plus 3y equals 12. And actually, we're going to replace x with 3. So 2 times 3 plus 3y equals 12. 2 times 3 is 6. So I got 6 plus 3y equals 12. I will subtract 6 from both sides. 6 minus 6 is 0. 0 plus 3y is 3y. 12 minus 6 is 6. So I get 3 times y equals 6. And I will divide both sides by 3. Keep breaking my pencil. 3 divided by 3 is 1. 1 times y is y. 6 divided by 3 is 2. So I get y equals 2. So my answer is xy equals 3, 2. Now there are a couple other situations that pop up, and I've got problems for those. So let's jump on here. In the one we just looked at, what was nice was we had this great coefficient of 1 that we could use to our advantage. In this next situation, we're not quite that lucky, but we can still get away with only having to multiply one equation by something. So let's say we have 9x plus 3y equals negative 33, and 3x plus 5y equals negative 7. You'll note that the x's have different coefficients and the y have different coefficients. I also do not have a 1 coefficient. Each of these variables has a number next to it that is not a 1. What I did notice was this right here. 3 is a factor of 9. What I mean is I can make 3 into 9 by multiplying it by 3. So I'm going to multiply that, or I'm going to do that. And I just have to remember that I have to multiply all of the terms in the equation. That's the only way I'm following the rules of algebra exactly. So 3 times 3x is 9x, 3 times 5y is 15y, and 3 times negative 7 is negative 21. And then I would just copy this other one on top here. So we've got 9x plus 3y equals negative 33. We do have one other issue. If you remember, we're supposed to be able to add down and get 0. Well, 9 plus 9 is not 0. So what I need to do is change some signs. And as long as you change all of the signs in an equation, it's fine. So I'm going to make 9x negative 9x. I'm going to make plus 15y plus negative 15y. And I'm going to change this negative 21 to positive 21. And now I will add down. 9 plus negative 9 is 0. So the x's are canceled. 3y's plus negative 15y's is negative 12y's. And that will equal, let's see, negative 33 plus 21 would be negative 12. I will divide both sides by negative 12. And I get that y equals 1. Now I can go back. It doesn't matter which equation I use, but I can plug 1 in for y. I'm just going to use the top one. 9x plus 3 times 1 equals negative 33. 3 times 1 is 3. So 9x plus 3 equals negative 33. I subtract 3 from both sides. And I get 9x equals negative 36. Bear with me, that was the bell, but I'm going to finish this. Then we'll divide both sides by 9, and x equals negative 4. So my answer is xy equals negative 4, 1. Now there is one other situation that we need to look at, and that is that you don't have a 1 coefficient like example 4, and you don't have a coefficient that is a factor of another coefficient, like in example 5, we're going to have example 6, and that is where you have no coefficients that are any of those things with each other. So there's no anything that you can use to your advantage. In this case, it's anybody's game. You can do whatever you want. So let's say, for example, I have 5x plus 2y equals -1 and 3x plus 7y equals 11. You'll note that the x's have coefficients, but neither of them is a 1 and neither of them is a factor of the other. The y's also have coefficients. Again, neither of them is a 1, neither of them is a factor of the other. So what we're going to have to do is multiply both equations by something. And then what I'll do is that'll force a coefficient that's the same. And I don't care what. I'm just going to use the x's because they're handy. They have coefficients 5 and 3. Well, 5 times 3 is 15. So I'm going to make my new coefficients of x 15. To do that on top, I need to multiply by 3. To do that on the bottom, I need to multiply by 5. Let's do the top. 3 times 5x is 15x. 3 times 2y is 6y equals 3 times -1 is -3. On the bottom, 5 times 3x is 15x. 5 times 7y is 35y. And 5 times 11 is 55. Once again, I have this issue where my coefficients of x are the same, but they're different. Or they're the same signs, excuse me. They need to be different. So I'm just going to change this on the bottom, make it -15, -35, and -55. That's going to work. The x's cancel. 6y's plus -35y's is -29y's. And then that will equal whatever -3 minus 55 is. It's going to be -58. I will divide both sides by -29. And I get that y equals 2. Then I can just plug that back in. It doesn't matter which one. I'm just going to go with the top. I'm going to go 5 times x plus 2 times 2 equals -1. 2 times 2 is 4. So I can do that. And then I got 5x. Then I will rewrite 5x plus 4 equals -1. And now I can solve. So I will subtract 4 from both sides. On the right side, -1 minus 4 is -5. On the left side, 4 minus 4 is 0. And 5x plus 0 is 5x. So I now have 5 times x equals -5. I will divide both sides by 5. 5 divided by 5 is 1. 1 times x is x. I get ahead of myself sometimes. -1 divided by 5 is -1. So x equals -1, which means my answer is xy equals -1, comma 2. Boom. Thanks for playing, and I will see you in class.